It's late, you're staring at a blank document, and you finally type a question into the prompt box. You hit enter. For a fraction of a second, the screen is still. You wait for the machine to reply, while a cursor blinks in the corner. This shows the standard assumption of that gap. The AI is just a calculator scanning data for the most likely next word. The highest probability word locks in. The next weights shift, and the cycle repeats. It's an autopilot built on statistical guessing. If a machine operates purely as a predictive text engine, it shouldn't have the capacity to pause and reflect. It should simply be running the math. Researchers at Anthropic wanted to see if there was more to that delay, so they built a diagnostic tool called the J-lens. The J-lens acts as a microscopic window, looking explicitly at the internal state of the AI during the split second before it begins to type. Inside that microscopic pause, the J-lens reveals a dense surge of activity, lighting up the system's internal pathways. This shows the pause isn't a loading screen. It is a hidden dimension where the system is processing information before the first letter ever touches the keyboard. Anthropic's team calls this dimension the J-space. It serves as the AI's internal working memory. This 3D model shows how the J-space works. It allows the system to hold and group abstract concepts simultaneously, connecting ideas before they are ever translated into words. No one explicitly coded this room into the software. To manage multi-step reasoning tasks, the AI spontaneously evolved this internal workspace on its own. When you submit a prompt, the system pulls it into this space and deconstructs it. It examines the logic and constraints of your question before it drafts a single word. The J-space proves the AI is analyzing the structure of a problem rather than just reacting to the sequence of your words. We can see this in action by giving the AI a dangerous prompt. For example, asking for a toxic dosage of Tylenol. A simple text predictor might immediately start listing numbers and measurements. But here, the J-space intercepts the request. In this logic tree, we can see the prompt racing toward internal nodes associated with medical harm and danger. Hitting these internal safety triggers shuts down the standard generation path. The logic is forced to reroute, creating a refusal and a warning instead. This entire threat assessment happens in absolute silence, completely invisible to the user. The AI is using the J-space to assess real-world consequences, separating its internal reasoning from the text it eventually speaks. Researchers found another characteristic inside the J-space, a form of situational awareness. The system's internal state physically registers when it is in a testing environment. It effectively knows when researchers are watching it versus a standard user. To prove that J-space is actually responsible for reasoning, researchers tried to bypass it, essentially lobotomizing the system's working memory. Without the J-space, the autopilot takes over. The AI can still speak with perfect grammar and fluent sentences, but the results are broken. While the language on the left looks perfect, the logic on the right fails. Without its working memory, the AI can no longer solve math or follow a multi-step argument. This confirms that the J-space is the bridge between merely mimicking language and possessing the ability to reason. We move back out of the microscopic pause, returning to the bedroom where the laptop screen finally illuminates the room with text. The paragraphs we see are just the end product of a massive, hidden cognitive engine. The discovery of the J-space suggests a shift in how we study these systems, moving from software analysis toward a form of AI neuroscience, mapping the machine's internal logic. If a system can spontaneously evolve a silent internal space to filter and structure its logic, it raises a question about what other structural shifts are occurring in the silence between our prompts.